Hello everyone, welcome to Victory Pure English Batch for Class 11 JEE NEET. This is me Arvind Suthar. I welcome you all in this session on circles. Today we're going to complete circles in one shot. I hope that your preparation for JEE is going good and you guys are putting your full efforts into this journey, because this journey is so much beautiful that once you will end up this journey, you will come to realize that this is one of the biggest investment that you have made in your life, because this challenging journey is going to change your personality a lot. And it does not matter much whether you are able to clear this examination or not, but the most important part of this journey is this will give you some of the amazing traits which are required in each and every successful person around you or across the nation, right? So I hope that you people are enjoying this journey. So in this journey today we're going to talk about circles. We will be completely covering all the concepts required to master this particular topic, and I will be giving you a lot of questions as well. DPPs are also provided to you. So I would like to tell you one thing before I begin this session is you can in very less time you will be able to cover all the concepts from this particular lecture, all the concepts required. And after that, what you have to do is nothing but practice, because JEE is a kind of examination where you need to solve a lot of questions, because there is so much learning from the questions. It's not like that if you watch this one video you will be able to solve each and every question, but I can definitely tell you that you will be able to command over each and every concept. Now you have to use these concepts in the problem solving, and you have to get a good confidence over the topic. All right, here we go towards our session. So number one, a circle is what? Circle is locus of the point in two dimension. Locus of the points in two dimensions such that its distance from a fixed point, that is center, is always a constant equal to radius. If you observe over here, all these points lie in a two-dimensional plane, and also what happens over here is that a fixed point is given to us, whom we call as center, and the distance of all those moving points from the center is always equal to a constant, and that is called as radius. Yes? All right. So in order to write down the equation of circles, just like the equation of straight lines, we need two things, okay? If you remember, in order to write down a straight line, we need either 2 points or 1 point and a slope, or 2 intercepts or something like that. Same, exactly on the same pattern, in order to write down the equation of a circle, we require two things. One is center and another one is radius. Yes, this is nothing but known as center radius form of a circle. Whenever you see such kind of an equation coming in front of you, you can directly say that it is a circle. And why do we call it as center radius form is because by just looking at this equation we can say what is our center of the circle and what is our radius of the circle. Observe over here, if you put this expression equal to 0, x minus h equal to 0, what you get is nothing but x equal to h, and if you put this expression y minus k equal to 0, what you get is nothing but y equal to k. Now these 2 points h comma k, that is x comma y, over here is h comma k, is nothing but center of the circle. So by just looking at this equation, you guys can say that h comma k are the coordinates of the center of the circle, and whereas this equal to r square thing, if you observe, then this is nothing but radius ka square. So your radius of the circle is going to be r only. So if let's say an equation of a circle is given to you like this, then I hope you can tell me what exactly is the center of the circle. 3, 4, yes or no everyone? And what is the radius? The radius is 2, because 2's square is written over here, and that is equal to 4. So the radius is going to be nothing but equal to 2. So by just looking at this equation, you guys can tell that what is the center and radius of the circle. That's why we call that particular equation or this particular equation over here as center radius form. Now if the center of the circle is 0, 0, we do call those circles as standard circle. So the equation of standard circle is going to look like this. Yes or no everyone, do let me know. So standard circles are the circles whose center is nothing but 0, 0. Always remember this. Alright, moving ahead. Find the center and radius of this following circle. There has to be no confusion at all. 5, 3 is going to be the center of the circle. And what is the radius of the circle? Radius of the circle is going to be 20 or root 20? Root 20. Root 20 is going to be radius of the circle, because over here r square is written always. Yes or no, everyone? Okay, so we need to find out the equation of the circle which is centered at origin and having radius equal to 4. So by using center radius form, we can write down the equation of the circle like this. Yes or no, everyone? So the moment you simplify this equation becomes x square plus y square equal to 16, and that is nothing but our circle having center 0, 0 and radius 4. Okay. So there are, just like different forms of equations of straight lines, there are different forms of circles as well. Okay. Over here, if you see, over here is this particular form. This particular form of a circle is known as diametric form of a circle. Diametric form of a circle. Now what do we understand by diametric form of a circle? If let's say the end points of the diameter are given to me, let's say x1, y1 and x2, y2. These are diametrically opposite end points of a circle, then we can write down the equation of circle by using these directly. Okay, yes, these are diametrically end points of a circle. Now how many diameter does a circle have? Infinite, isn't it? So out of those infinite diameters, if let's say the end points of one diameter, that is x1, y1 and x2, y2 are given to me, then by using these alone I can write down the equation of circle. How do we write it down? Is x minus x1 times x minus x2 plus y minus y1 times y minus y2 equals to 0. This is nothing but known as diametric form of a circle. Let's say 1, 3 and 2, let's say minus 3. These are the two end points of the diameter given to me. Then by using these points, I can write down the equation of the circle quite comfortably. That is x minus 1 times x minus 2, y minus 3 times y plus 3, and just add these two quadratics and put it equal to 0. This is nothing but the equation of circle. Equation of circle having a and b as diametric endpoints. Equation of circle having a and b as diametric endpoints. Diametric endpoints means the endpoints of the diameter. Okay. Yes, I hope you guys are clear with this. Now observe over here, sometimes in the problem what happens is, let's say like this, okay, this is a quadratic equation, this is a quadratic equation, okay, this is some kind of a quadratic equation given to me, and its roots are x1, x2, let's say, and another quadratic in y is given to me like this, and it is given to me that the roots of these the roots of this quadratic in y are y1 and y2, and it is given to me in the problem that these are the two end points of the diameter. The x1, y1 and x2, y2 are the end points of the diameter. Now considering these 2 points as a diameter, write down the equation of circle. Okay, considering these 2 points as diameter of the circle, write down the equation of the circle. So in that case, what we do is we simply add these two quadratics. Yes or no? Because this expression is, because if this equation is having roots x1 and x2, then this can also be written as x minus x1 times x minus x2. Yes or no, everyone? And if this equation is having roots y1 and y2, then the same expression can also be written as y minus y1 times y minus y2, and we have just seen that x minus x1 times x minus x2 plus y minus y1 times y minus y2 equal to 0 is nothing but equation of the circle having x1, y1 and x2, y2 as the diametrically endpoints only. So the equation of this circle can also be written as x square minus ax plus b plus y square minus cx plus d equal to 0. Observe one thing over here, and that is what? If over here in the quadratic equations the coefficient of x square and y square are not given to me equal to 1, then we first make a coefficient of x square and y square equal to 1. We first make coefficient of x square and y square equal to 1. Okay, always remember this. All right, moving ahead, I hope this particular thing is clear to you. So let's take this question up and let's try to solve this one. Find the equation of the circle with this and this as the endpoints of the diameter. So we can write it down comfortably: x minus 2 times of x plus 3 plus y plus 3 times of y minus 5 equal to 0. Yes or no? Anyone is having any confusion in this? Feel free to reach out to me. I don't think there has to be any confusion at all. All right, moving on to the next thing. One of the diameters of the circle circumscribing the rectangle ABCD is this given to me. If A and B are the endpoints, if A and B are the points, this and this, find the center of the circle. All right, so we can understand that if let's say this is a circle, okay, then one of the diameters of the circle circumscribing the rectangle, okay, this is a rectangle ABCD, this is a rectangle ABCD, ABCD is given to me. So all these angles are 90 degree, 90 degree. I said okay, and over here it is given to me that the coordinates of A and B are A's coordinates are minus 3, 4. B's coordinates are 5, 4. Let me tell you one very important thing, that in the case of coordinate geometry, in every portion of coordinate geometry, whether it is straight line, circles, parabola, ellipse or hyperbola, first try to draw the picture of the given question. From there you're going to have a lot of idea. Okay, so over here you can feel that the A and B are both having y coordinates equal to 4. That means, can you say that this line is going to be parallel to x-axis, because a line parallel to x-axis has an equation y equal to constant. And over here at these 2 points A and B, if you see, the y coordinates are nothing but equal 4, 4. So we can say that this is a line parallel to x-axis only. Okay, now considering that in mind, the coordinates of x coordinate of D has to be minus 3, yes or no, and the x coordinate of C has to be 5 only. Why? Because if this line is parallel to x-axis, and since this is a rectangle, AD and BC has to be parallel to the y-axis, and the equation of any line parallel to the y-axis will be nothing but x equals to constant. So over here at D point also the x coordinate has to be minus 3, and at C the x coordinate has to be equal to 5. All right, let's move ahead. Now there is one diameter 4y equal to x plus 7 given to me. I said okay, 4y equal to x plus 7 given to me. Can I just see this equation and find out whether this line is passing from any of the 4 coordinates A, B, C, D? Let's see. If we put x equals to minus 3, then y's value is going to be equal to 1, so it is not passing from A. If I put x equals to 5, then the y's value will be equal to 3, so it is neither passing from B as well. So we can say that since it is a diameter and a line does have infinite and a circle has infinite diameters, so let's say this is one of the diameter 4y equal to x plus 7. Okay, now every diameter pass from the center of the circle, yes or no? And also if you remember, the diagonals of a rectangle bisect each other. The diagonals of a rectangle bisect each other. So by using that, can we somehow solve our question, everyone? Let me see. If we say that the x coordinate is, let's say, alpha, then the value of the y coordinate over here is going to be what? The value of the y coordinate is going to be alpha plus 7 by 4. Yes or no? Since the center of the circle will be lying on the diameter. Yes. So by putting x equals to alpha, we got the value of y as alpha plus 7 by 4. Now understand that the diameters, the diagonals of a rectangle bisect each other. That means what? If we take the midpoint of B and D, it has to be this point only, that is center of the circle, and if we take the midpoint of A and C, it has to be this particular point only. Yes or no, everyone? Yep. Okay, if we do that, I hope we can comfortably get to our question. There has to be no difficulty at all. So we can see that the midpoint of B and D has to be midpoint of B and D will be what? 5 plus minus 3 by 2 comma something, some y coordinate will also come, so it has to be 1 comma something. Yes or no? It has to be 1 comma something. So alpha's value you guys can assume as nothing but 1. Yes or no? Because the midpoint of B and D and the center of the circle has to be same. So alpha's value is coming out to be 1, and if alpha's value is coming out to be 1, the value of alpha plus 7 by 4 is going to be 2. So the center of the circle is going to be 1 comma 2. I hope you guys are clear with this particular question. All right. Coming on to third form of the circle, and that is known as general circle, and that is known as what? And that is known as general circle. The equation of general circle is written over here: x square plus y square plus 2gx plus 2fy plus c equals to 0. There is no other choice. You will have to remember this equation as it is. X square plus y square plus 2gx plus 2fy plus c equals to 0 represents nothing but equation of a circle only. Observe over here, the coefficient of x square and y square are both 1 1, and this is a general equation which we have studied in the last class. That is general equation of a 2-degree curve: ax square plus by square plus 2gx plus 2fy plus 2hxy plus c equals to 0. In that equation, if a and b are both 1 1 and h is equals to 0, then that particular equation represents a circle. So that's why we get something like this. Okay, yep. So let me tell you, as of now you can remember this equation: x square plus y square plus 2gx plus 2fy plus c equals to 0. This represents equation of a circle, and the moment we see such kind of an equation, we do observe that x square and y square's coefficient is equal to 1. If it is not 1, then make it 1, or we can also say that x square and y square's coefficient are equal. Yes or no? Okay, and there is no xy term in it. There is no xy term in it. And only in these cases this equation will represent nothing but a circle. Okay, now the moment you have this equation, you can write down the equation, or you can write down the coordinates of the center of the circle and radius quite comfortably. The center's coordinate, there is one way to write down the coordinates of the center. The moment the coefficient of x square and y square is 1 1. First, if the coefficient of x square and y square are not 1, then first make it 1. The moment you have made the coefficient of x square and y square as 1 1, you can write down the coefficients of center as: take the coefficient of x, that is 2g, take the coefficient of y, that is 2f, and multiply these two things by -1/2. What you get is nothing but the coordinates of the center only. The moment coefficient of x square and y square, the coefficient of x square and y square are made 1, what you do in order to find out the center of the coordinates of the circle, the coordinates of the center of the circle is, you take coefficient of x, that is 2g, you take coefficient of y, that is 2f, and multiply these two things by -1/2. So ultimately you get -g comma -f, and that is nothing but coordinates of the center of the circle. Okay, yes. In this case, if you want to find out the radius of the circle, then what you do is, do the square of -g, you're going to get g square. Do the square of -f, that is y coordinate of the center of the circle, you're going to get f square. And add these two things and subtract from here the c. And just take an under root, what you get is nothing but the radius of the circle. So the radius of the circle in that case will be equal to under root g square plus f square minus c. Again, I'm telling you, whenever an equation like this is given to you, that is the equation having terms x square, y square, x, y and c, that is 5 terms. What you do is, you first make the coefficient of x square and y square equal to 1. The moment you have made the coefficient of x square and y square equal to 1, you write down the coordinates of the center of the circle as -g comma -f, and the radius of the circle as under root g square plus f square minus c. Okay, do remember these things. Okay, so as I just told you that the 2-degree general equation ax square plus by square plus 2hxy plus 2gx plus 2fy plus c equals to 0. This is a general equation of a 2-degree curve. Then understand that when does this represents a circle is, number 1, coefficient of x square equal to coefficient of y square, and there is no xy term in it. If these two things are satisfied in this equation, then we say that this equation represents a circle. I hope you people remember that whenever delta is equal to 0, delta was what? abc plus 2fgh minus af square minus bg square minus ch square. If that thing is 0, then this equation represents pair of straight lines. Whereas if these two conditions that I have just talked about, that is coefficient of x square and coefficient of y square, that is a and b are equal, number 1, and if there is no xy term in it, means the value of h over here is 0, then this equation will represent nothing but a circle. Okay, now in a circle, the radius is under root of g square plus f square minus c. So radius is nothing but under root g square plus f square minus c. So in that case, understand, if anything is written inside the under root which is positive, then this is going to be a real number, and if anything inside the under root is negative, then that is going to be an imaginary number. So if radius is coming out to be imaginary, we do call those circles as imaginary circle, whereas if radius is a real number, then we do call those circles as real circle. Also, if the radius of a circle is 0, then we say that it is a point circle. So let me tell you one interesting fact over here, that a point is also a circle with radius equals to 0. This point is also a circle with radius equal to 0. This is an amazing fact, isn't it? A point is also a circle with radius equals to 0. Alright, show that this equation represents a circle. Now understand, over here the coefficient of x square and the coefficient of y square are equal, and there is no xy term in it, so this has to be nothing but an equation of circle only. How to identify whether an equation is of circle or not? The coefficient of x square, the coefficient of y square has to be both equal, number 1. Number 2, there has to be no xy term in it, then it will represent a circle. Now, the moment you have identified that this is an equation of circle, in order to write down the center and radius of the circle, what you do is, you first make the coefficient of x square and y square equal to 1. So for that, you need to divide this equation by 3. The moment you do that, what you're going to have is something like this. Something like this, yes or no? The moment you have made coefficient of x square and y square equal to 1, 1, now you can write down the coordinates of the center. In order to write down the coordinates of the center, I told you one thing, take the coefficient of x, take the coefficient of y, multiply these two things by minus 1 by 2. What you're gonna get is nothing but the coordinates of the center. So over here, these values will be coming out to be minus 2, 3. I hope you understood this one. Okay, what is the radius of the circle? In order to write down the radius of the circle, I told you one thing. Under root of square this particular thing, 4 square this particular thing, 9 minus this constant term. So over here the constant term is already minus 11 by 3. So by simplifying this, you can write down the radius of the circle as well. I hope you guys are clear with this. You can simplify this, and this is nothing but your radius of the circle. Okay, moving ahead. Coming to another form of equation of circle, and that is parametric equation of a circle. Parametric. Now understand that, let me tell you one very interesting fact over here. Okay, if I'm assuming, I'm talking about standard circle first. Okay, standard circle means the circles having center 0, 0. If the circle is having center 0, 0, then any point on the circle, can be assumed as r cos theta, r sin theta. Then any point on the circle can be assumed as what? If the center of the circle is 0, 0, then any point on the circle can be assumed as r cos theta, r sin theta. Okay, what exactly is r? R is nothing but the radius of the circle, and what exactly is this theta is, the moment you join any point on the circle with center of the circle, that is origin in this particular case, this line will be making some angle with the positive direction of the x-axis, right? Yes, over here you can see that this is the theta. So this is the angle theta. Okay, I hope you can understand that, since if you want to write down any of the point on the circle, you will have to move like this from 0 to 360 degree or 0 to 2 pi. So this theta over here goes from 0 to 360 degree. 0 to 2 pi, 0 degree to 2 pi, or 0 to 2 pi. Yes, I hope you guys are clear with this. Any point on the circle, standard circle, let me tell you this interesting fact over here, that this particular thing, if a circle is a standard circle, then parametric equation for the standard circle can be written like this. Parametric equation can be written like this. Parametric equation can be written like this: x equal to r cos theta and y equal to r sin theta only. Also, if you want to take assume, whenever it is required that assume any point on the circle, you will use what? Parametric equation. So any point on the circle can be assumed as r cos theta, r sin theta. Again, I am telling you, a lot of guys don't understand that when to use parametric form. We need to use parametric form whenever we need to assume any point on that particular circle. Just like parabola, ellipse and hyperbola. If any point on the curve we need to assume, we will take what? We will take parametric points we will assume parametric equation of a circle, or like this. I hope you people understood this, and this is very important thing. whenever you need to assume any point on the circle, you will use what? Parametric coordinates. I hope this thing is in your mind now. Okay, a very important thing. Okay. Yep. All right, moving ahead. So understand that if a standard circle is given to you, the parametric equation will be written like this, and if you need to assume any point on the circle, you will assume it as r cos theta comma r sin theta. I hope you guys are fine with this. Okay. Now, if the circle is not standard, let's say the circle is having centered at h comma k, then in that case what you're going to do is, over here you have taken x equal to r cos theta and this y equal to r sin theta. On the similar pattern, if you see, you will assume this x minus h value as r cos theta. The moment you assume x minus h equal to r cos theta, you can say that the value of x is going to be what? H plus r cos theta. It is written over here. And you will assume this y minus k equal to r sin theta. So the value of y is going to be what? K plus r sin theta. So in this case, if you want to assume any point on the circle, you will assume it as h plus r cos theta comma k plus r sin theta. Okay, you can also feel that if h and k are 0, then you will put h and k as 0, 0 over here. You will ultimately fall where? You will ultimately fall in the standard circle only. I hope you guys are clear with this particular thing. Okay, over here h and k is nothing but, h comma k is nothing but center of the circle. Now let's say if general equation is given to you, then you can write down the center over here is minus g comma minus f. So just feel that h comma k was the center over here. So in place of h, if you put minus g, and in place of k, if you put minus f, then your parametric coordinates will be looking like this. I hope you guys are clear with this particular thing. Okay, problems on parametric equation. Write the parametric equations of a circle like this. Understand, is this a circle? The coefficient of x square and y square are both same, number one, and there is no xy term in it. So this has to represent an equation of circle only. So this can first be rewritten as something like this, and this can further be rewritten like this. Yes or no? Now over here the radius of the circle is 5 by 3, so x can be taken as r cos theta, that is 5 by 3 cos theta, and y can be taken as r sin theta, that is 5 by 3 sin theta. I hope you guys are clear with this particular thing. Alright, yep, moving ahead. Find the parametric representation of the point on the circle. Is this equation representing a circle? First let me know about that. Yes, obviously. Why? Because coefficient of x square and y square are same and there is no xy term in it. Okay, I told you always, whenever you see this kind of a general equation, what you do is you make the coefficient of x square and y square equal to 1 first. So the moment you do that, that is, if you divide this equation by 3, what you're gonna get is something like this, everyone. Yes. Alright, so this is what you have as of now. I said fine. Okay, now if you remember, we have seen what the parametric coordinates will be written like this: center x coordinate plus radius times cos theta, and the y coordinate is written as centers y coordinate plus radius times of sin theta. Yes or no, everyone? Yep. So here if you see, the center's x coordinate is going to be what? Minus 1 by 2 into minus 4 by 3, that is equal to how much? 8 by, you can say it is 4 by 6, and center's y coordinate, if you talk about center's y coordinate, then center's y coordinate is going to be what? Minus 1 by 2 times of minus 6 by 3. So that is going to be how much? 6 by 6. I'm not cancelling these terms. You can cancel these as well. There will be no difference in that. Okay, so this is going to be what? This is going to be 4 by 6, and this is going to be what? This is going to be 6 by 6, or 1 also we can say. Okay, number 1. Now what is going to be the radius? The radius of the circle is going to be 4 by 6 ka whole square plus 6 by 6 ka whole square minus of c, and the c's value over here is already minus 4 by 3, so let's put it, and this value is what you're going to put over here in place of radius, and what you get is nothing but the parametric equation of the circle in these cases. Alright, express the following equation of the circle in Cartesian form. If the curve is a circle, find its center and radius. Alright, now the moment you see that this is a parametric equation, can you guys feel that it is something like x equal to h plus r cos theta and y equal to k plus r sin theta? If yes, then you can feel it quite comfortably that this is going to be equation of circle. Also, what happens sometimes in the form of parameters, equations are given to me and the question tells me to write down it in the form of only x and y, that is excluding or eliminating the parameter theta. So we do call those equations in the form Cartesian form. Okay, Cartesian form means the equation which are in the form of x and y alone, not in the form of parameters. So over here theta is a parameter. Now ultimately our agenda is to eliminate theta from here. So how do we eliminate theta? We can write down this particular thing first like this, okay, and from here if you see we can write down this particular thing as y minus 3 equals to minus 3 sine theta. Okay, if we square this particular thing, then we will be having x minus 2 ka whole square equal to 9 cos square theta, and if we square over here we can write down y minus 3 ka whole square equal to 9 sine square theta. We're gonna call this equation as equation number 1. I'm gonna call this as equation number 2. The moment we add 1 and 2, don't you think that the theta will be eliminated? So the moment we add 1 and 2, we can see that it is coming out to be x minus 2 ka whole square plus y minus 3 ka whole square equal to 9 cos square theta plus 9 sin square theta. Cos square theta plus sin square theta is nothing but equal to 1. So we can say that this is nothing but equation of the circle only. What is the center of this circle? 2, 3. What is the radius of the circle? 3. I hope you guys are clear with this. So sometimes what happens, equation is given to me in the form of parameters, and our agenda is to eliminate the parameters and write down the equation in terms of x and y alone, whom we call as Cartesian form only. Okay, moving ahead, talking about a new concept, and that is concentric circles. Concentric circles means circles having same center, circles having common center. Common center means same center. If there are two circles whose centers are same, we call those circles as concentric circles. Let's say a circle having center h comma k is given to me, and we need to write down concentric circles to that. So how many circles can have a same center? How many circles can have a same center? Infinite, isn't it? Infinite number of circles can have same center. Yes or no? Everyone, do let me know. So if it is given to me that two circles are concentric, first I'll do understand from that is the circles are having same center. The circles are having same center. So in case of, if these are the two circles given to me, are these two concentric circles? Yes, obviously. Why? Because their centers are same. So understand, the concentric circles do have same center, but the radius is different. Only these constant terms are different. Rest all the terms, if you expand this also, x square plus h square minus 2xh plus y square minus 2ky plus k square equal to r1 square. Over here x square minus 2hx plus h square plus y square minus 2ky plus k square equal to r2 square. So you will observe that the coefficient of x square is same in both of these equations, the coefficient of y square is same in both of these equations, the coefficient of x is same in both of these equations, the coefficient of y is same in both of these equations. So we have seen that an equation of circle have 5 terms in it: x square, y square, x, y and a constant term. So out of these 5, if these 4, that is x square, y square, x and y, these 4 terms are having same coefficients, then we say that these two equations are what? These two equations are of concentric circles, because they do have change only in constant term, rest all the terms are same. So find the equation of circle concentric with this particular circle. So as I just told you, this much portion of the circle is going to be same since these are concentric circles. So we can write down the required circle like this, and since it is given to me that it is passing from 5, 4, so 5, 4 has to satisfy the equation of the circle. So our required circle is going to be what? Our required circle is going to be 25 plus 16 minus 8 5 is 40 minus 48 plus c equals to 0. Find c from here. Find a c from here. The moment you got the value of c from here, just put it over here, and what you will get is nothing but the equation of the desired circle. I hope this thing is clear to all of you guys. There has to be no confusion at all. Alright, talking about this, find the equation of the circle having center at this and which touches this particular line. Though this question should not come over here, but still it has come. So this equation is of this question is of family of circles. In case you have studied it already, in case you have studied this topic, then I am explaining it over here. In case you haven't, then once I'll complete this lecture, you will be able to understand this question. So over here it is given to me that a circle is having 2, 3 as the center, and over here is, let's say, one line. Obviously the point 2, 3 is not lying on the line, 2, 3 is not lying on this particular line. So I am drawing the line over here, x plus y equal to 1. So the question is like this, that our center of the circle is this, and the circle is touching this particular line. So we need to write down the equation of this particular, circle. So we can first find out the perpendicular distance between the center and the straight line. Yes, I hope you know, we have already studied this in straight lines, how to find out the perpendicular distance between a point and a line. So we can write it down like this: 2 plus 3 minus 1 divided by under root 1 square plus 1 square, and by the way, this is nothing but radius of the circle, so let me call it as r. So r's value is going to be what? 4 divided by root 2, so that is equal to 2 root 2. Yes. Okay, now I told you what, in case you remember, in case you are aware of the radius and center of the circle, you can write down the equation of the circle quite comfortably. So your equation of the circle will be written as x minus 2 ka whole square plus y minus 3 ka whole square equal to 2 root 2 ka whole square. So this is your equation of the desired circle, right? I hope you guys are clear. I told you what, in order to write down the equation of circle, you need to have two things. One is center of the circle, another one is radius of the circle. Over here, center of the circle is given to me, radius was not given. So since the circle is touching this line and having center 2, 3, I can find out the perpendicular distance between those two things, and that is going to be nothing but equal to the radius. And once we have got the radius, which we have studied how to find out, this perpendicular distance in the chapter straight lines, and the moment we have radius, we can write down the equation of the circle quite comfortably. So if the line this and this are diameters of the circle which passes through the point 2, 6, find out its equation. Okay, there are two diameters of the circle given to me. So diameters of a circle intersect at what? Diameters of the circle intersect at center. Yes or no? So by solving these two lines, can we find out? By solving these two lines, can we guys find out the center? Yes, by solving these two lines, we can find out the center. Okay, it is given to me in the problem that our circle is also passing through 2, 6. Is 2, 6 lying on any of these lines? No. So over here it is going to be 2, 6. Okay. So understand that in order to write down the equation of circle, you need to have two things. One is center, another one is radius. Now, if you solve these two lines, you will be able to have the center with you, and the distance between center and this point is nothing but radius only. So you can find out r as well the moment you have got the center. If you have both of these things, can you write down the equation of the circle? Everyone do let me know. So can you guys do this question on your own now? Yes. So I'm giving you this part of question as homework. So I'm calling it as homework number 1. I hope you will be able to do this without any difficulty. Now, there are very specific cases where the circle touches x-axis, the circle touches y-axis, the circle touches both the axes, and so on. Okay, so these are some very special cases, and will come very frequently in the problem solving. So let's say you have been given that your circle is touching x-axis. Okay, so what do you understand from that? Now understand, let's say if this is your road, okay, and if this is wheel of the any bus or car or whatever, if it is moving, can you tell me this distance is going to be what? If this is the center of the circle, if this is center of the circle, this distance is going to be what? This distance is going to be equal to radius of the tire or not? Everyone feel it. This is center. So the distance between road and center of the tire is going to be equal to radius of the tire or not? Yes or no, everyone? Now, I hope you know that if this point is, let's say 2, 3, then this perpendicular distance from the x-axis is going to be what? 2 or 3? This perpendicular distance is going to be 3 only. Yes. So over here, if this is radius of the circle, can I say that these points will be having y coordinate as r only? Yes sir. Okay. In this case also, if you see, the center will be having y coordinate equal to r only or not? Okay, let me tell you one thing, that above x-axis y is always positive and below x-axis y is always negative. So in these cases, if you see, the center of the y coordinate will be minus, the y coordinate of the center will be minus r or not, and over here also the center of the y coordinate will be minus r or not, because below x-axis y coordinate has to be negative, and as I just told you that since this distance is equal to radius of the tire, so it has to be equal to, it will be having y coordinate, the center will be having y coordinate in magnitude equal to its radius only. So over here r, over here minus r, okay. Yes, over here if it is given to me that this is a point a comma 0, then I know that on this vertical line x is going to remain constant or not. So can I say that this center will be having coordinates a comma r, this center will be having coordinates a comma minus r. This circle will be, if this point is minus a comma 0, let's say, where the circle is touching x-axis, then the coordinates of this point is going to be minus a comma r, and the coordinates of the center of the circle is going to be minus a comma minus r. Yes or no? So if it is given to me my circle is touching x-axis, then any of these four cases can be there. Yes or no? Your circle can be in the first, your center of the circle can be in the first quadrant, it can be in the second quadrant as well, it can be in the third quadrant as well, it can be in the fourth quadrant as well, the center of the circle. And the moment center changes, I hope you people know that the equation of the circle is going to change. Yes or no? Because a circle's equation is dependent on two things. One is center of the circle and another one is radius. I hope you guys are clear with this. Okay. Moving ahead now, there can be scenarios in which a circle is touching y-axis. Let's say it is given to me that this point is 0 comma b, and over here it is given to me, let's say 0 comma minus b. I hope you know that on the y-axis x is always 0. Yep. Okay. Now if r is the radius of the circle, can you guys tell me the coordinates of the center of this particular circle? It is going to be r comma b. Yes or no? Everyone do let me know, because if this is a point 2 comma 3, if this is a point 2 comma 3, then we can say that this distance is going to be how much? 2. Yes or no? So if this thing has to be clear to you guys. Yes. Okay. So this point will be having coordinates r comma b. What about this? Minus r comma b, because x coordinate is going to be negative in the second quadrant, and by the way radius is always positive. So that's why minus r comma b. Okay. Over here if you see, it is going to be minus r comma minus b, and over here if we talk about what will be the coordinates, r comma b. You can also feel it like this, that if let's say this is some vertical road, and over here if your vehicle is moving, so by that logic also you guys can feel it. Okay. Now if the circle is touching both the axes, now this is a very important thing. Understand that if this is a circle touching both the coordinate axes, then from here this and this has to be equal, and if this and this are equal, can you say that the coordinates of x and y has to be equal? In the first quadrant both of them has to be positive only, so it is going to be r comma r only if r is the radius of the circle. If the circle is touching in the second quadrant, then it is going to be minus r comma r. If the circle is touching in the both the axes in the third quadrant, it will be minus r comma minus r, and if the circle is touching both the axes in the fourth quadrant, it will be equal to r comma minus r. So the moment it is given to you that your circle is touching x axis, y axis, or both axes, you can have an idea about the x and y coordinates of the center of the circle. Yes, I hope you guys are clear with this particular thing. Alright, moving on to the next problem. The center of a unit circle. Unit circle means the radius is equal to 1. Okay, yes. Touching these lines at 1 comma 1. We need to write down the center of a unit circle which is touching the line x plus y equal to 2 at 1 comma 1. Okay. Now this is something different. It should not be over here, but still it has come. So let me draw. X plus y equal to 2 is one of the line given to me. So the line is going to look something like this. If you put x equals to 0, y's value is going to be this. So over here it is going to look like this. Okay, yes, so this is your y equal to minus x plus 2 line, and over here is some point 1 comma 1, and over here in the problem it is given to me that the center of the unit circle touching the lines this and this at 1 comma 1. Okay, unit circle means the circle is having radius 1 comma 1. Sorry, the circle is having center, we don't know, but radius is equal to 1. It can be like this as well. Yes, so there can be there can be two circles of radius 1. There can be two circles of radius 1. One can be like this, one can be like this. So obviously two answers has to come, yes or no, number 1. Okay, now if you understand one thing over here, that the slope of this line is minus 1. Okay, the slope of this line is minus 1, means the slope of, if you join this point, if you join this point with the center of the circle, the slope of that line will be equal to minus 1 or not, because if in case you have studied about normals and tangents, I hope you know that normals and tangents are perpendicular to each other. So in the case of circles, normal always passes through center of the circle, yes or no? So this line has to be perpendicular. This line has to be perpendicular means if the slope of this line is minus 1, then the slope of this normal has to be 1 only. Now what do we understand from that? We do understand from that is the coordinates of the x coordinate and the y coordinate of the center of the circle has to be same. X and y coordinate of the center coordinate of the center of the circle has to be same. Center of the circle has to be same, because then only the slope will be equal to 1. Yes or no? Because it has to pass from 1 comma 1 also. So if the slope of this line is 1, then center of the x coordinate and y coordinate also has to be same. Yes, has to be same. So in case you understood this, so you can assume the center as alpha comma alpha, and if this is the case, then I hope you know that the distance between these 2 points alpha comma alpha and 1 comma 1 can be represented like this, and since it is a unit circle given to me, so this distance I can put as 1. So alpha minus 1 ka whole square plus alpha minus 1 ka whole square equal to 1 after squaring, and the moment you solve this equation, it is going to be 2 times of alpha minus 1 ka whole square equal to 1. So alpha minus 1 ka whole square equal to 1 by 2, giving us alpha minus 1 equal to plus minus 1 by root 2. So the value of alpha is going to be what? Plus minus 1 by root 2 plus 1. Yes or no? So two coordinates will come. One will be 1 by root 2 plus 1 comma 1 by root 2 plus 1. Another one will be minus 1 by root 2 plus 1 comma minus 1 by root 2 plus 1. So over here, if you see 1 by root 2 plus 1 comma 1 by root 2 plus 1, so this is one of the option, and another option is going to be what? Minus 1 by root 2 plus 1 comma minus 1 by root 2 plus 1. So over here no such options are given, so the option is only A. Okay, so two answers will come in this particular thing. One will be 1 by root 2 plus 1 comma 1 by root 2 plus 1, another one will be minus 1 by root 2 plus 1 comma minus 1 by root 2 plus 1. So I hope you guys are clear with this particular question. Alright, moving ahead. If the lines, these cuts coordinate axes at 4 concyclic points. Concyclic points means points lying on the same circle. Concyclic points means points lying on the same circle. Points lying on the same circle. Points lying on the same circle. On the same circle. Okay, yes, if this is the case, let me tell you one concept over here. So the concept says, if a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0, if these are the two lines and they are cutting at coordinate axes and those 4 points are concyclic, then in that case a1 a2 has to be equal to b1 b2. a1 a2 has to be equal to what? b1 b2. So over here, if you see, the value of a1 is 2, the value of a2 is a over here, the value of b1 is 3, and the value of b2 over here is nothing but equal to 2. So you can say that a is equals to 3 only. So the value of a is coming out to be 3. Yes, so the answer is going to be C for Calcutta. Okay, this is one concept. If these two lines are cutting coordinate axes at 4 points and those 4 points are concyclic, then a1 a2 has to be equal to b1 b2. a1 a2 has to be equal to b1 b2 only. I hope you people understood this particular thing. Okay, moving ahead. Alright, talking about this, now this is one such question. A variable circle through point a comma b touches x-axis, then find the location of the other end of the diameter through a. What I have observed over the years is locus, the problems involving locus are difficult for the kids, but let me tell you guys, if you have seen my straight lines video, then I can tell you there is a Brahmastra by which you can solve each and every question of locus. There my idea is what? You need to find out one point which has to satisfy the equation of locus, and whichever option is satisfying that particular option can be your answer, and like that you eliminate the options and you proceed in order to solve the question, right? Yes, so let's understand how smartly I am going to solve this particular question. You can solve this in a subjective manner as well, but rather if you want to clear this examination, then you will have to think smart, because JEE is looking for smart people, and if you show your smartness, then your chances of clearing this examination are going to be high. So here we go, a variable circle passing through a comma b touching x-axis. Okay, understand, if a circle is touching x-axis, we have just seen that we can assume it like this. Okay, this is a circle touching x-axis. Alright, now a comma b is a point given to me on the circle. I said okay, so this circle has to pass from a comma b. Now there are infinite circles possible. So infinite circles possible means a comma b, for one circle a comma b will be over here, for one circle another circle a comma b will be over here, for another circle a comma b will be over here, for another circle a comma b will be over here, for another circle a comma b will be over here, because number of circles passing from a point a comma b can be infinite. Yes or no, everyone? Are you guys agreeing with me on this or not? From a single point, infinite circles can be drawn, right? Let's say this is one point. How many circles I can draw passing from this particular point? Infinite, like this, like this, like this. Okay, like this, like this, like this. Infinite circles can be drawn by passing from a single point, yes or no? So over here, a comma b is given to me. So from passing from that point, infinite circles can be drawn. For one circle, a comma b will be over here. For one circle, a comma b will be over here. For one circle, a comma b will be over here, and like that. Yes, everyone, you guys agree with me on this or not? So I hope you guys can understand this much. All right, if I'm saying you that this point is a comma b for this particular circle, a comma b. Now I'm assuming that this has diametrically endpoint which is lying on a horizontal line. So we can say that if this is a horizontal line, then these 2 points also have x coordinate equal to y coordinate equal to b only, because I'm assuming that these points are lying on a horizontal line. Yes, because out of those infinite points, out of those infinite circle, one circle will be such that a comma b is lying on this particular point. That means if I draw diameter parallel to x axis, then center of the circle will also be having b coordinate, and this another diametric endpoint will also be having the y coordinate as point b only. Now understand, if this is the thing, then what is the radius? In this particular case, the radius of the circle is going to be a only. So in that case, this length is also going to be a only. If this length is a, can you tell me that what will be the coordinates of the center of the circle? A comma b. Okay, sorry. Yes. Wait a minute. So what we need to do is we need to move a distance. We need to, sorry. Then this distance is going to be what? Wait. This is not b. This is going to be what? If this is a comma b we have taken, then since this line has to be y equal to constant, so the y coordinates will remain b only. Okay, talking about the x coordinate over here, if I'm assuming that this is having b as the y coordinate, then this length is going to be how much? This length is going to be b only, yes or no? Because if there was a point 2, 3, then if the circle is touching x axis, then the radius of the circle will be nothing but equal to 3. So over here the radius will be b, yes or no? Can you guys feel it? If yes, then the coordinates of this point will be what? A plus b comma b, and the coordinate of this point is going to be what? B more than that. So it is going to be a plus 2b comma b, yes or no? Can you guys feel this or not? Let me tell you this thing once again, that if over here is the center of the circle 2, 3, and I'm telling you that the circle is touching x axis, okay? Yes, so in that case, can you tell me what will be the center of the, what will be the radius of the circle? Yes, absolutely, because this distance has to be equal to 3, yes or no? So if a circle is touching x axis, then the center of the y coordinate of the center will be equal to radius only. This is what we have seen. So if the center is having y coordinate as b, then the radius of the circle has to be b only. So if the radius of the circle is b, then from here if we move b units towards right, we're going to get the center. So the coordinates will be a plus b comma b, and from center if we move b units ahead, we're going to get the another endpoint of the diameter. Yes or no, everyone? Can you guys feel this? Okay, if you can feel this much, then your question is done. You can feel that your circle has to pass from a plus 2b comma b. Okay, in which of the following points, if we put a plus 2b comma b, the equation is getting satisfied. Let's see. If you put x equals to a plus 2b over here, it is going to be 4b square, and y equal to b, it is going to be 4b square. So this equation is getting satisfied. Okay, over here if you put x equal to a plus 2b, this is going to be what? 4b square, and this is going to be 2b square. So this is not satisfying the another end point of the diameter. So this is not our answer. Talking about this, if you see, if you put a plus 2b over here, it is going to be what? a plus b ka whole square equal to something else. A plus b ka whole square equal to something else. So this will not be satisfying a plus 2b comma b, and this I think also will not be satisfying a plus 2b comma b. So what is going to be your answer? Your answer is going to be option A only. That's it. The question is done. So that's what I'm telling you. A locus will contain infinite number of points. From those infinite points, out of those infinite points, if you are able to find out any few points which has to satisfy the equation of the locus, then you can see which of the following options are satisfying those points, because that only are going to be your answer. So based on this, you can do the elimination and your questions can be solved quite comfortably. All right, moving on to the next thing. The circle this and this is inscribed in a triangle which has two of its sides along the coordinate axis. Okay, Find the locus of the circumcenter of the triangle. Okay, the circle, this is inscribed in a triangle which has two of its sides along the coordinate axis. Okay, all right. So you can see that if this is your triangle is inscribed in a triangle. Okay, so over here your circle is going to be like this. Yes, okay, and it is having center 2 comma 2, and what is the radius? And the radius is also equal to 2 only. Yes or no, everyone? Have a look at this. So this is how your scenario will be looking like. Okay, if this is the case, we need to find out the locus of the circumcenter of each of this kind of triangle. Okay. Okay, so if this is the case, then first can we find out these 2 points? If yes, then our question will be done. Yes or no? Okay. So understand one thing from here is, and that is what, that if this is 2 comma 2, and we can assume this line. Okay, the radius of the circle is 2, by the way. Yep. Okay. So can we guys write down? This perpendicular distance has to be equal to 2. So can we write down over here any point whose distance from 2 comma 2 is going to be equal to 2? If yes, then our question will be done. Okay. So let's write down any of the equation whose distance from 2 comma 2 is going to be equal to 2 only. The moment we have done that, our question will be solved. Okay. Yes, so let's try to write it down. I don't think it is going to be difficult at all, because look, understand that which has 2 of its sides. Okay, find the locus. Okay, so can we write down these lines will be infinite in number. The perpendicular distance always has to be equal to 2. If this is changing, the circumcenter of the triangle will always change. Okay, so it is going to be, okay, for a right angle triangle, since this is a right angle triangle only, we have seen that circumcenter is going to be what? Midpoint of the hypotenuse. Midpoint of the hypotenuse. Yes, everyone, we have seen this in the last class. Okay, if this is the case, then we can do one thing. That we can, we can assume this point as alpha comma alpha. Yes, because that will be one such possibility. Okay, from 2 comma 2, if you find out the distance between alpha comma alpha and made it equal to 2, so alpha minus 2 ka whole square plus alpha minus 2 ka whole square under root will be equal to 4. So 2 times of this equals to 4, means alpha minus 2 ka whole square equal to 2. So it is going to be alpha equal to 2 plus root 2 comma 2 minus root 2. Okay, so alpha comma alpha can be 2 plus root 2 comma 2 plus root 2, and it can be 2 minus root 2 comma 2 minus root 2. Yes or no? Okay, so let's take alpha as 2 plus root 2 comma 2 plus root 2. In this case, if you see, kids, so 2 plus root 2 comma 2 plus root 2, where is it getting satisfied? 2 plus root 2 comma 2 plus root 2. In which of the following options 2 plus root 2 comma 2 plus root 2, and also 2 minus root 2 comma 2 minus root 2 is getting satisfied? Let's see. If you put x plus y equal to this, so it is going to be 4 plus 2 root 2. If you multiply this, then it is going to be 6 plus 2 root 2. Okay, x plus y is going to be what? X plus y, if we are taking these values, okay, it is going to be 4 plus 2 root 2. Okay, x into y, if you do, in case these are the values, then it is going to be 4 plus 2 plus 4 root 2. Okay, if you subtract these two equations, then it is going to be what? Okay, no, it is not getting satisfied in this case. Okay, so this is not our answer. Similarly, this is not our answer. Okay, and if you see over here, so I think these two equations are going to be identical only in that case. Yeah. Okay, so this has to satisfy, both of these equations has to satisfy. So let me put it like this: 4 plus 2 root 2, so 6 plus 4 root 2, so 6 plus 4 root 2, Okay, there is some error in the options as I can see, but there are multiple ways to solve this question. Let me give you another trick. Okay, let me give you another trick, that if this is the case, then the circle is having center 2 comma 2. The circle is having center 2 comma 2. Okay, so you can assume that let's say this line you can feel. Okay, this perpendicular distance has to be equal to 2. This is what given to us, and if we are taking this point as, let's say, okay, we take this white line as x by a plus y by b equal to 0, equal to 1, sorry, an intercept form of the straight line, then in that case this point is going to be what, a comma 0, and this point is going to be what, this point is going to be 0 comma b, 0 comma b. Okay, and somewhere over here, let's say midpoint is coming a by 2 comma b by 2. Okay, so this is going to be midpoint of the hypotenuse, so this is going to be circumcenter of the triangle. Okay, so from this line what we do is we make the perpendicular distance of 2 comma 2 equal to radius. Yes, okay, so let's do that. Perpendicular distance of the point 2 comma 2 from that line, if you do 2 by a plus 2 by b plus 1, sorry, minus 1, perpendicular distance of the point 2 comma 2 from x by a plus y by b equal to 1 line, okay, divided by 1 upon a square plus 1 upon b square, and this has to be equal to 2. So the moment you see this, this is going to be what? This is going to be 2 by a plus 2 by b minus 1 ka whole square equal to 4 times of 1 by a square plus 1 by b square plus 1 by no, that's it. Okay, simplify this equation, you're gonna get an equation in a by b, in a and b. So you can see that we need to find out the locus of the circumcenter, so we can put it as h comma k. So it is going to be how much? It is going to be a equal to 2h and k equal to b equal to 2k, and we can put it over here, and the equation which we get in terms of h and k is going to be our equation of the locus. So this is subjective method, we can put over here a equal to 2h and b equal to 2k, and what we gonna get is nothing but our equation of the locus. So this is subjective method. By solving this, I think you will be able to get the equation of the locus. Over here the options are not correctly given because I can feel that there is some misprint over here somewhere in the options alone, because this point 2 plus root 2 comma 2 plus root 2 has to satisfy the answer by the objective trick that I just told you, and it will satisfy, there is no doubt about it. Okay, yes, find the equation of the circle with center this and touching the x-axis. Okay, so having center this minus 2 comma 3, minus 2 comma 3 is going to be where, beta? Minus 2 comma 3 is going to be somewhere over here. So the radius of the circle is going to be what? The radius of the circle is going to be 3. That's it. So can you write down the equation of the circle? X plus 2 ka whole square plus y minus 3 ka whole square equal to 3 ka square. So this is your desired circle. That's it. Alright, position of a point with respect to a circle. So there can be 3 relations between a point and a circle. Either the point can lie inside the circle, either the point can lie on the circle, either the point can lie outside of the circle, right? These 3 relations can be there. Now understand, if x1 comma y1 is one point given to me and one circle's equation x square plus y square plus 2gx plus 2fy plus c equals to 0 given to me, then if I want to find out of these 3 cases which of the following case between the point and a circle is getting satisfied, so what we do is we call this particular thing as S1. Now understand, what is this S1? We remove this portion equal to 0 from the equation of the circle first, and in this thing, in place of x we put x1, in place of y we put y1. Whatever the value we are getting, we do call that as S1. I hope you understand what is S1 now. Okay, then if the value of S1 is coming out to be negative, we say that the point x1 comma y1 is lying inside the circle. If the value of S1 is coming out to be equal to 0, we say on the circle, the point is lying on the circle, and if the value of S1 is coming out to be greater than 0, then we say that the point x1 comma y1 lies outside the circle. Okay, I hope you guys are clear with this. Alright, talking about this question in this particular case, find the values of a so that this point lies inside the region bounded by these circles and the line x plus y equal to 2. Okay, so understand, this is a circle having center at 0 comma 0 and radius equal to root 5. Yes or no? So our circle will be drawn like this. Okay, can you tell me that this point is going to be what? Root 5 comma 0. This point is going to be what? 0 comma root 5. This point is going to be what? Minus root 5 comma 0. And this point is going to be what? 0 comma root 5. Yes or no? Because the radius of the circle is 0 comma minus root 5. That is this, right? Okay, now x plus y equal to 2. If you try to draw this line x plus y equal to 2, you can see that when you put x equals to 0, the y value is going to be 2. So over here it is going to be 0 comma 2, and over here it is going to be 2 comma 0 the moment you put y equal to 0. So your line will be drawn like this. So this is our line y equal to minus x plus 2. Okay. Now the question is saying that find the value of a so that the point lies inside the region bounded by this and this. That means this region. Okay. In this region, if your a comma a plus 1 lies, then what should be the value of a is what the question asking me. I hope the question is clear to all of you guys. So as I told you, first try to draw the diagram. From there you're going to get a clear picture how to proceed in order to solve the equation. Okay. Now number one thing is the point has to lie inside the circle. So we can say that a comma a plus 1, if you put inside the equation of circle, it has to give us a negative sign. So we can say that this expression is going to be negative, number 1. Okay, moving ahead. Now understand, if we take this line x plus y minus 2 equal to 0, okay, if you put origin inside this, the value of this is going to be negative. So that means what? If we put any point below this line inside this expression, it has to give a negative sign only, because out of these infinite points, one point is 0 comma 0, and when we are putting it over here, it is giving us a negative sign. So what we want is the opposite side of those points containing origin. So whenever we put a comma a plus 1 in this expression, it has to give us positive sign as per the region given to us. So the moment we put a comma a plus 1, what we get is something like this, greater than 0. Just solve these two equations. What we're gonna get is nothing but our answer. So the answer is going to be 1 intersection 2. That is the common region between these two conditions, right? So I hope you're gonna get your answer quite comfortably without any difficulty, right? I don't think that this equation is difficult to solve. Over here you can see that a has to be greater than 1 by 2. If a has to be great, from here alone you can say that 2a minus 1 greater than 0 means a has to be greater than 1 by 2. A has to be greater than 1 by 2 means this will not be our answer, this will not be our answer, this will not be our answer. The answer has to be option B. You don't even need to solve a 1 and 2. From 2 alone you can say that B for Bombay is going to be the answer, yes or no. So that's what I'm saying you, if this question comes in your examination, you don't even need to solve 1 and 2 and then you there is no need to take this long process. From here itself you can say that 2a minus 1 will be greater than 0 means a has to be greater than 1 by 2. So in any ways you have to take a greater than 1 by 2 only. So there is only one option which contains the value greater than 1 by 2, and that is option B. So that has to be your answer. Number of integral values means number of integer values. Okay, integers are what? 0 plus minus 1 plus minus 2 plus minus 3 plus minus 4 and so on, of P such that 1 comma 4 lies inside the circle this, and the circle does not meet any of the coordinate axes. Now the circle does not meet any of the coordinate axes is a very important point. Let me tell you, if a circle is cutting x-axis like this, okay, then this particular distance is known as its x-intercept. This particular distance is known as what? X-intercept. And the formula for this is twice of under root g square minus c. If a circle is, let's say, cutting y-axis like this, then the distance between these 2 points is nothing but its y-intercept. The distance between these 2 points is nothing but y-intercept, and the value of this is twice under root f square minus c. If a circle is not meeting any of the coordinate axes, means what? This is imaginary. This is imaginary. That means if a circle is not meeting any of the coordinate axes, then that means g square minus c has to be negative, as well as f square minus c will be negative. So this is one very important takeaway that you should keep in your mind. Okay, number of the integral values of b such that this point lies inside the circle. Okay, alright, so we can say that when we put this point 1 comma 4 inside this, the value should be negative. So let's put it 1 plus 16 minus 6 minus 40 plus p has to be negative. So the value of p should be what? Minus 10. Minus 10 is minus 50, then p has to be less than 49. Number 1. Okay, over here if you see, the value of G is -3, the value of F is -5, the value of C is P. Okay, so you can see that G square minus C should be negative, G square minus C should be negative, means 9 minus P should be negative, means P should be less than 9. Okay, and F square minus C should also be negative, F square minus C should also be negative, means 25 minus P should also be negative, means P has to be greater than okay, P has to be greater than 9. Over here P has to be greater than 9, and over here P has to be greater than 25. Okay, so this is one equation, G square minus C should be negative. This is another equation, F square minus C should be negative, and this is third equation. So all these three has to be satisfied in this problem, yes or no? So by taking the intersection 1, 2 and 3, you can say that your P will go from where to where? Your P will go from 25 to 49. So how many integral values are written over here, kids? P has to be greater than 25, P has to be, okay, so the number of the integral values of P such that the point lies inside this particular circle. So wait a minute, 1, 4, right, 1 plus 16 minus 6 minus 40 plus P minus 46. Minus 46 means, okay, sorry, there is some calculation mistake I have done, plus 10 minus 30, this is 29. Okay, and if this is 29, over here 29 will come. So between 25 and 29, how many integral values do come? 26, 27, 28, 3 values. So the answer has to be C for Calcutta. So again I am telling you, look, if a circle is cutting x-axis at two distinct points, then the distance between those 2 points is known as its x-intercept, and that's formula is twice of under root G square minus C. If the circle is cutting y-axis at these two distinct points, then the distance between these 2 points is known as y-intercept of the circle, and that distance is written as twice of under root f square minus C. So over here it is given to me that circle does not meet any of the coordinate axes, means G square minus C, that is the thing which is written inside the under root, has to be negative, so that's why there is no x-intercept. And over here there is no y-intercept, means f square minus C should also be negative. So 2 equations I have written from there, and also the point is lying inside the circle, so when we put this point inside this should give us negative value. So talking about these 3 things, we take the intersection, and what we do get is our P's value is going from 25 to 29. So how many integer values are coming in this interval is 26, 27, 28, that is 3 values. I hope you guys are clear with this particular question. Okay. Now another concept is greatest and shortest distance of a point from a circle. Now let me explain you this. I hope you guys remember that if this is a circle and if this is a point, let's say, okay. Now a circle is having infinite points, an external point is given to me, and the question is asking me, find out the greatest distance between this point and this circle. Okay, now look, there can be infinite distances between this point and this circle. If this point I am taking on the circle, then this will be one such distance. If I am taking this point on the circle, this will be the distance. If I am taking this point on the circle, this will be the distance. If I am taking this point on the circle, this will be the distance. If I am taking this point on the circle, this will be the distance. So there are infinite distances between a point and a circle. Out of those infinite distances, one will be maximum, one will be minimum, yes or no? Because if there are infinite distances, there will be one maximum value and one will be minimum value. Okay, now let me tell you, the shortest and the greatest distance lies along the common normal. What am I telling you? The shortest and the greatest distance lies along the common normal. Normal is something which passes through the center. Okay, so if this is your center, now understand, the shortest and the greatest distance lies along the common normal, means if you are drawing a normal passing from this external point to the circle, the shortest distance and the greatest distance will lie along that. So over here you can see that this particular distance is going to be shortest when it is a normal, and this particular distance when this line is a normal is the greatest distance. This is one very important concept. The greatest distance and the shortest distance lies along the common normal. Okay, remember this. Okay, if the coordinates of the center are given to you, let's say this point is A given to you and the coordinates of the center is given to you as B, then the shortest distance is going to be what? You can do AB, the distance between AB minus radius, yes or no? Because this is going to be a radius. So from this distance, if you subtract this radius, you can get the shortest distance. Whereas if you want to have the greatest distance, what you can do is you can write down the distance between A and B point and just add radius to this. You're going to get the greatest distance between the point and the circle. So what am I telling you is, if a point is given to you and if a circle is given to you and the question is asking you about greatest and shortest distance between a point and a circle, then the shortest distance and greatest distance between the point and the circle lies along the common normal. The shortest distance will be written as modulus of AB minus R, and the greatest distance will be written as modulus of R plus AB. Though these are the distances, they always has to be positive only. Okay, so this is the concept. So the greatest distance will be CP plus R, that is C is the center, P is the point. So look, the greatest distance also lies along this common normal only, and the shortest distance will also lie along this common normal only. So this is very important concept. Alright, let's talk about this question. Find the greatest and the shortest distance of this point from the circle this. Okay, what is the center of the circle? The center of the circle is 2, 1, yes or no? What is the radius of the circle? The radius of the circle is going to be 5, yes or no? Okay. Okay, when we put this point inside the circle, is the point lying inside the circle or outside the circle? I think outside the circle, somewhere over here, or you can also see it. Okay, can you guys find out the distance between center and this point? Okay, the distance between AC can be written as under root 8 square plus 6 square, that is equal to 10, yes or no? So this distance is equal to 10. Okay, from this 10, if you subtract the radius, you will get the shortest distance. So the shortest distance is going to be 5, 10 minus 5. And the greatest distance is going to be what? It is going to be this distance plus radius, that is equal to 15. So this is going to be our answer. Alright, talking about this particular question, find the point on the circle which is nearest to the point. Nearest means shortest distance. Okay, so over here you can feel that if this is the circle, okay, the center of the circle is going to be what? 2, minus 3. Okay, and somewhere over here is, let's say, some point 7, 2 given to me, and we need to find out the shortest point on the circle. That means the point whose distance from this point is going to be minimum. Okay, yes, so it will lie along the common normal, yes or no? So can you guys write down the equation of the normal in this case? Yes, 2 points are given to you, A and C. So the lines of the equation of the line AC will have slope what? It will be having slope 2 minus 3 divided by 7 minus 2. So that is going to be what? 5, 5. So that is will be equal to 1. Okay. The moment you have written the slope as 1, you guys can write down the equation of line like this. 1 times of x minus 7. Now if you solve, one way is you can solve this equation of the straight line AC with this circle. Solve 1 and 2 to get the answer. Solve 1 and 2 to get the answer. Another way is through parametric form of a straight line. That also you guys can do. Let me tell you the parametric form of a straight line. 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 Yes. X minus x1 upon cos theta equal to y minus y1 upon sin theta equal to r. Now, if you look it closely, x minus x1 equal upon cos theta equal to r can also be written as x minus x1 equal to r cos theta and y minus y1 equal to r sin theta. Now you will be confused, sir, is this equation of a straight line or is this the equation of circle? Now let me tell you one amazing fact, that this can represent both. This can represent a circle as well as a straight line. This can represent a circle as well as a straight line. Now understand, where is the difference? If r is constant, and theta is parameter, if r is constant and theta is parameter, this is going to represent a circle. Whereas if theta is constant and r is parameter, this is going to represent a straight line. If r is constant and theta is parameter, this equation is going to be of a circle, whereas if r is parameter and theta is constant, this equation is going to represent a straight line. A lot of kids who even pass class 12th are not aware of this particular fact. So always remember this particular thing, number one. Okay, yes, as you guys know that I told you when to use parametric form. We need to use parametric form whenever we need to assume a point on the curve. When do we use parametric form? We use parametric form whenever we want to assume a point on the curve. So over here, understand that since this line is given to me AC, because it is very easy to find out the line AC. Now I want to assume a point on this curve, so that's why I am going to use parametric form of a straight line. Now understand. I am telling you method 2 to solve the particular question. Okay, this is 1.7 comma 2 given to us, and this is the center of the circle 2 comma minus 3, and the radius was what? The radius, if you evaluate over here, the radius is going to be what? Under root 4 plus 9 plus 3. So that is going to be how much? 13, 16, 4. Okay. So this radius is 4. So over here at a distance r units, that is 4 units, we want to find out the coordinates of this particular point. Yes, this is the question given to us. Okay, now slope of this line is equal to 1. Yep, that means theta, angle of inclination, is going to be 45 degree. So over here we guys can see that x minus 2 upon 4 equal to y plus 3 upon, okay, cos theta, that is cos 45 degree, and over here sine 45 degree is equal to r, that is 4, because we want to write down points on this line having a distance 4 from this particular point 2 comma minus 3. Yes or no? So that's how we're gonna write down the points. So these points can be written as x equals to 2 plus 4 into cos 45 degree. So that is equals to 2 plus 4 by root 2. So that is equals to 2 plus 2 root 2. Okay, and over here if you equate this with this, you can write y equal to minus 3 plus 4 sine 45 degrees. So that will be equal to what? Minus 3 plus 2 root 2. Okay, so this point having the shortest distance on the circle will be what? 2 plus root 2 comma minus 3 plus 2 root 2. 2 plus root 2 comma minus 3 plus 2 root 2. That means what? C for Calcutta is going to be the correct answer. So this is method 2 in order to solve the question. The method 1 was what? The method 1 was solving equations 1 and 2 to get the point of intersection. Method 2 is by using parametric form you can solve this particular question. I hope you guys are fine with this. Yep, alright. Intercepts. Okay, if this is the circle and if this is cutting x-axis at these 2 points, then the distance between these 2 points I told you will be called as what? X-intercept. The formula for that is under root twice of under root g square minus c. And if the circle is cutting y-axis at these 2 points, the distance between these 2 points is nothing but y-intercept. The formula for that is twice of under root f square minus c. Okay. Yes. Find the x-intercept made by this particular circle on the coordinate axis. So as I told you, the value of g is going to be 7. The value of f is going to be what? Minus 7 by 2. And the value of c is going to be what? 12. So x-intercept is known as what? X-intercept is twice of under root g square minus c. Put in the formula, you will be able to have your answer. Y-intercept will be what? Y-intercept is going to be equal to twice of under root f square minus c. So I hope you guys are clear with this particular question. Okay, now talking about a circle and a line, there can be 3 relations between a line and a circle. Okay, let me talk about this. If let's say this is your circle, now how can a line and a circle interact? Either this line will be completely outside of the circle, or the line will be a tangent to the circle, or the line will be cutting at 2 distinct points to a circle. Yes, these are the only 3 relations possible between a circle and a line. Either the line will be away from the circle, or the line will be touching the circle, or the line will be cutting the circle at 2 distinct points. Now understand, over here is the center of the circle. If the distance between this line and the center of the circle is less than its radius, then can you say that the line will be cutting the circle at 2 distinct points? Okay, so if this perpendicular distance is less than radius, if the perpendicular distance P is less than the radius of the circle, then we say that line cuts the circle at 2 distinct points. Line cuts circle at 2 distinct points. Okay. If the perpendicular distance between center and the line is equal to its radius, like over here, if perpendicular distance, that is P, is equal to the radius of the circle, then we say that line is a tangent to the circle. Whereas if this perpendicular distance is greater than the radius of the circle, if this perpendicular distance is greater than the radius of the circle, we say that line does not interact with the circle. Line does not interact, there is no interact with the circle. or there is no intersection of the circle with the line. Okay, yes, that's it. So this is one very important takeaway. All right, I hope you know how to find out a distance between a line and a point. That formula we have studied in straight lines. Okay, so we have to use that concept over here. The line this cuts the circle at two distinct points, then this is going to be what? So over here we can see that center of the circle is going to be 2, 4 and the radius of the circle is going to be how much? 4 plus 16, 20, that is 5. Okay, so ultimately we need to have the distance between 2, 4 and this line lesser than radius. Yes, then only the line will be cutting at two distinct points. So we can say that 3 into 2 minus 4 into 4 minus k is modulus divided by under root 3 square plus minus 4 ka whole square. This is the perpendicular distance. This has to be equal to, this has to be lesser than the radius. By just solving this equation, you will be able to get to your answer. So this is going to be what? This is going to be minus 10 minus k by 5 has to be less than 5. I hope you know that this can further be written as modulus of 10 plus k itself and going to be this. So your 10 plus k has to go from minus 25 to 25 and from there you can find out the value of k, where k will go from minus 35 to 15. So this is your final answer, right? These equations are quite easy to solve. I have covered these equations in the chapter Basic Mathematics. If you are having any confusion about solving these equations, you guys can refer that video as well. Okay. Yes, okay. If the line this is touching the circle this, then find the value of lambda. So if the line is touching the circle, then the perpendicular distance has to be equal to the radius. So the center of the circle is 1, minus 1. The radius of the circle is going to be what? It is going to be 2 minus lambda. Okay, so if you find out the perpendicular distance, 3 plus 4 plus 1's modulus divided by under root, okay, divided by 5 and putting it equal to root of 2 minus lambda, you can get the answer, find lambda from here. Okay, and the question is done. Because the line is a tangent means perpendicular distance has to be equal to the radius. Okay, if this line touches the circle this, then find the point of contact. I don't think it is difficult at all. Method 1 is calling this equation as 1, calling this equation as 2. Since we have already got the value of lambda, we can solve 1 and 2. Solve 1 and 2, that is one way. Or you can also see that the moment you have got the values of lambda, now whatever is the answer has to satisfy both objective method, method 2. Objective method is that, objective method. Answer has to satisfy both 1 and 2. So whichever option is satisfying both 1 and 2 will be your answer, has to satisfy both equation 1 and 2. Okay, let me talk about this. That let's say this is your circle, okay, and this is your tangent. So point of contact is this particular point. That means the tangent is contacting the circle at which particular point, that is the point at which tangent is drawn. So this point, this one will be common in both circle and tangent or not? Yes. So that is how I am telling you the objective tricks. I hope you guys can solve it like this as well. Method 1 is you can solve these two equations and the common point is nothing but the solution of the two equations, and that will be your point of contact only. There is one more way. Let me talk about that. And that is what? This is the circle. This is method 3 I am talking about. Okay, over here the slope of this line is what? The slope of this line is 3 by 4. So the normal has to have a slope minus 4 by 3. Yes or no? Because if the two lines are perpendicular, then their product of slope is equal to minus 1. Okay, since we already know the center of the circle, it is 1, minus 1, and now we can assume these points and we can say that which of the following equation is having slope equal to minus 4 by 3 will be your answer. So like this also you can eliminate the options and the question can be done quite comfortably, kids. Alright, find the radius of the circle centered at this and touching the circle this externally. Also find the intercept made by it on the line this. Okay, you won't be able to solve this question as of now because you need to study that if two circles are touching externally, then the distance between the center C1 C2 equal to R1 plus R2. Like this, I'll teach you today, and then only you will be able to understand this question. So I'm giving you this part as homework as of now. Once I'll complete the significant portion, you will be able to solve this question as well. All right, yes, talking about tangents, a very important subdivision of the problem. Now look, whenever point x1, whenever point is given to you on the curve, on the curve means if it is a circle, the point is given to you on the circle. If it is a parabola, the point is given to you on the parabola. If it is an ellipse, the point is given to you on the ellipse. If it is a hyperbola, point is given to you on the hyperbola. Whenever the point x1 comma y1 is given to you on the curve, t equal to 0 will represent equation of tangent, Okay, in order to write down t, you need to use these particular things. X square will be replaced by x into x1, y square will be replaced by y into y1. Okay, x will be replaced by x plus x1 by 2, y will be replaced by y plus y1 by 2. Okay, and constant will be left as it is. X into y will be replaced by x into y1 plus y into x1 by 2. Okay, this xy is not there in the case of circles, but this can be there in the case of parabola, ellipse and hyperbola. That's why I have told this. Okay, now understand. If I am telling you that at point x1 comma y1 draw a tangent. Now at point x comma y1 itself means the point is lying on the curve. So if this is the equation of the curve given to me, I will write down the equation of tangent by what? T equal to 0, because the point is given to me on the curve, number 1. In order to write down t, what we do is we replace x square by x into x1. So look, x square, x into x1. We replace y square by y into y1, and we replace constant as it is. Okay, so this is the equation of the tangent. Okay, if this is the circle given to me and the point x1 comma y1 is lying on the curve, and at that point if I want to draw a tangent, what we do is we can write down the equation of the tangent by t equal to 0, yes or no? So x square will be replaced by x into x1, y square by y into y1. This x will be replaced by x plus x1 by 2. This y will be replaced by y plus y1 by 2 and constant as it is. So this is going to be equation of the tangent at the point x comma y1. That means x1 comma y1 is lying on the curve. Okay. Parametric points. At parametric points, tangents we need to write down. So over here, if this is the case, then the parametric points are what? A cos theta comma a sin theta. Because the circle is a standard circle, yes or no? Okay, so in place of x1 we can put a cos theta, in the place of y1 we can put a sin theta, and the tangent is done. Okay, if this is the case, then also we can do, because we have seen that minus g plus a cos theta comma minus k, minus k comma that plus a sin theta we have seen, and in place of x1 and y1 we can put that point. Again I am telling you t equal to 0 will represent equation of tangent only in the case when the point is lying on the curve. T equal to 0 will represent equation of the tangent only in the case when the point is given to us on the curve, okay. Yes, moving ahead. Now there are cases in which we need to use a slope form of the tangent as well. So if this is a circle, standard circle, the tangent can be written as y equal to mx plus minus a under root 1 plus m square. Remember it by heart. If I am telling you that on this circle write down an equation of slope m, then that will be written as y equal to mx plus minus a under root 1 plus m square. You can also feel this, that if this is a standard circle, so the center is going to be origin of the slope m. How many tangents can be drawn? Feel it, 2 tangents. Of the same slope, 2 tangents can be drawn like this, same slope. Yes, that's why plus minus is coming over here. Alright, talking about this, if this is some standard circle given to me, non-standard circle given to me, that is a circle not having center 0, 0, that is a general circle. And if in that case we want to write down an equation having slope m, what we do is we first write down the equation of the tangent like y equal to mx plus c. Now, if a line is tangent to a curve, then the perpendicular distance of the line from the center of the circle has to be equal to radius of the circle. So the moment we say that this is a tangent, we do perpendicular distance from the center of the circle, that is minus g comma minus f of this line equal to radius of the circle, and by that we find out the value of the c. Okay, I hope you guys are clear with this particular thing. Okay, now this is tangents from the point. From the point means this point is not lying on the curve. This point is not lying on the curve. If you are using t equal to 0 to write down the equation of the tangent from the point x1 comma y1, that will be 0. You cannot write in this case x into x1 plus y into y1 equal to a square as the tangent. That will be wrong, because the point x1 comma y1 is not lying on the curve. I repeat, the point is not lying on the curve. That's why you cannot write x into x1 plus y into y1 equal to a square as equation of tangent. That will not represent equation of tangent. So the point is not lying on the curve means t equal to 0 will not represent equation of tangent, because the point is not lying on the curve. Okay, so rather what do we do over here is we first write down y equal to mx plus a minus a under root 1 plus m square. Okay, and we know that if this is a circle, let's say, if this is a standard circle, let's say, and the point is lying over here, let's say x1 comma y1, and if we are writing down a tangent from this, so the tangent there will be from an external point, so you can draw two tangents, by the way. Okay, yes, the tangents will be drawn like this. Any tangent will pass from this point as well, x1 comma y1. So look, this tangent has to pass from x1 comma y1, means in place of x you can put x1, in place of y you can put y1, and then by using this equation you will get the value of m, and the moment you get the value of m, you can write down the equation of tangent quite comfortably. Okay, similarly you will do over here as well. You will, since this is some circle given to you, this is coordinate axis, and over here is, let's say, you are having circle, and somewhere over here is x1 comma y1 given to you. Then from an external point, as I told you, two tangents can be drawn. One is like this, another one is like this, let's say. So what you do is you first write down the equation of the tangent like this: y minus y1 equal to m times of x minus x1. Now perpendicular distance of this tangent from the center of the circle has to be equal to radius. The moment you solve that equation, you will be able to get your tangent. Okay. Yep, normals. Normal of a circle always passes through center of a circle. Normal of a circle always passes through center of a circle. That's it. I don't think anything else is required. One is this, and another one, tangent and circles are always perpendicular. Tangent at a point and circle, tangent and normal at a point on the curve are always perpendicular. That's it. Nothing else is required. And in the case of circle, the normal always passes through center. Okay. Yeah. Problems on tangents and normal. Find the equation of tangents to this particular curve for this with the slope 7. Right. With the slope 7. So understand that what you're gonna do is you can assume the equation of, you can assume, as you can remember over here, this is a standard circle. Okay. And what we want is an equation of the tangent, an equation of the slope m. We can write down y equal to mx plus c. So let's say over here 7x plus c is the tangent. Now if this is a tangent, the perpendicular distance of this from the center of the circle, center is how much? 1, 2, and will be equal to radius of the circle. Radius is how much? 2 root 2. Yes. So let's do this. The perpendicular distance of this is our circle, 1, 2. This is our tangent, y equal to 7x plus c. The distance between these two should be equal to the radius, 2 root 2. So let's do this and your question is done. From here you will get the value of c. Okay. So 7 times of 1 minus 2 plus c is modulus divided by under root 7 square plus minus 1 ka whole square. This is how we write down the perpendicular distance, and just make it equal to 2 root 2. Find c from here. The moment you got c from here, put it over here, and what you will have is nothing but equation of the tangent only. Alright, talking about this, find the number of tangents which can be drawn from this point. Okay, understand, if this is a point, if this is a circle and if this is a point, no tangent can be drawn. So 0 tangents from here. If the point is lying on the circle, then how many tangents can be drawn? 1 tangent can be drawn. And if a point is lying outside, over here, so how many tangents can be drawn from an external point onto a circle? 2 tangents. Okay, remember this. One is like this, one is like this. Okay, and from here if you see, you can draw you can draw only one tangent, that is this. Okay, and from, if the point is inside the circle, you can draw 0 number of tangents. Okay, so we need to find out whether this point is lying inside the circle or on the circle. So we can see that the point is lying on the circle, yes or no? On the circle means one tangent can be drawn. So the answer is going to be option A. Okay, moving ahead, the points A and B are the feet of perpendicular drawn from origin on the lines this and this, then the circumradius of the triangle OAB is going to be what? I think you can do this, there has to be no issue at all. Feet of perpendicular, I hope you can find out. Yes, x minus 2y, so 2y equals to x plus 1 means this is going to be positive, so this is our line, 2y equal to x plus 1. From here I hope you can draw a perpendicular and you can find out the coordinates of this point. Okay, this is A point. So I don't think there will be any confusion at all. The slope of this is 1 by 2, so the slope of this will be minus 2, and this is origin, so you can write down the coordinates of A point quite comfortably. Yes, y equal to minus 2x, and just solve these two equations, solve 1 and 2 to get the coordinates of A, solve 1 and 2 to get A, and the moment you get A, similarly you can get B, and the moment you have got A, B and origin is already given to you, you can find out circumradius quite comfortably. Circumradius can be found out by the distance of the circumcenter from O, the distance of the circumcenter from B, the distance of the circumcenter from A will all be equal, and accordingly the question will be solved. Okay, tangents drawn from the point this to the circle will be perpendicular to each other. Okay, if all right, let me tell you this. Though this concept will come director circle, but let me tell you this. This is a circle having center 0, 0 and radius equal to 5. So that will be another way through director circle. Okay, but let me talk about this. If this is a circle and from here, let's say I am able to draw 2 perpendicular tangents. Okay, let's say from here I am able to draw 2 perpendicular tangents. Okay, so if you make use of geometry, then if this is our point alpha comma 5, let's say, okay, and this is 0, 0 being the center of the circle, if we draw like this is also going to be perpendicular and this is also going to be perpendicular. So as per the symmetry, can you guys say that this angle is going to be 45 degree? This angle is also going to be of 45 degree as well. Yep, and if this is the case, then radius of the circle you are already aware, 5. So this is the hypotenuse, so it will be 5 root 2. So the distance between alpha comma 5 and 0 comma 0 will be 5 root 2. So alpha square plus 5 square equals to 5 root 2. So alpha has to be plus minus 5. So mod of alpha will be 5 only. Yep, that's it. Yep, okay. Find the common points between this line and this circle. Okay, common points. Okay, we need to solve these two equations, nothing else. 1 and 2. Solve 1 and 2. Solve 1 and 2 to get common points, no doubt about that. Okay, yep, alright. Find the equation of the tangents to the circle drawn from the point, So the point, this is not lying on the curve, not lying on the circle. If this point is not lying on the circle, means you cannot use t equal to 0 to write tangent. Yes or no? Yes, number 1. Okay, then what do we do rather? We write down an equation of the tangent having slope m. So y equal to mx plus minus radius times under root 1 plus m square. This is equation number 1. Okay, then what do we do? Since it is giving to me that if this is your circle, over here is 1, 4, so the tangents has to pass from 1, 4 as well. Since it is an external point, 2 tangents can be drawn. So has to pass through 1, 4. So let's satisfy 1, 4 over here. So it is going to be 4 equal to m plus minus 4 under root 1 plus m square. Solve for m from here, and the moment you got the value of m, you can write down, put it over here, and the equation of the tangent will be there with you. I hope you guys are clear with this. Okay, if y equal to this is a normal to the circle, okay, the normal to the circle, so normal, first of all, the circle can be written like this. The circle's equation can be written like this, and the center of the circle is going to be what? Minus 3 by 4 comma minus 1. Yes or no? Yep. Okay, this is the center of the circle. Now the question is saying that this is a normal. So normal always passes through the center. Always passes through the center. So just satisfy minus 3 by 4 comma minus 1 over here. You can get k's value. Okay. Yep. All right. Moving on to the next question. Two tangents are drawn to the circle from the point this lying outside the circle. Okay, find the equation of the circumcircle of the triangle formed by joining the points of contacts and the point P. Okay. Understand that the center of this circle is what? The center of this circle is 3 comma minus 2, and the radius of the circle is what? 9 plus 4, that is 13. 4 is the radius. I said okay. Radius of the circle is 4. From here 7 comma 4 an external this is drawn, okay, and the tangents are drawn from this circle like this. One is this tangent, another one is this tangent, and okay, the circumcircle is going to be what? The circumcircle this, okay, this is not, you know, neatly drawn, so let me change the points so that you guys can feel it. Okay, this is one of the tangent, this is another tangent, this is perpendicular, this is perpendicular. So ultimately what we want is a circle passing through all these 4 points. Okay, the circumcircle. Okay, so whatever is the answer has to satisfy this, whatever is the answer has to satisfy 7 comma 4 as well as 3 comma minus 2 and so on. Yes or no, everyone? Okay, so from there also you can have an idea that what is going to be the thing, right? And also this you can write down the equation of the circle considering these 2 points as diameter, so that will be circumcircle only. So x minus 7 times of x minus 3 plus y minus 4 times of y plus 2 equal to 0. So that equation is coming out to be x square minus 10x plus 21 plus y square minus 2y minus 8 equal to 0. So x square plus y square minus 10x minus 2y, okay, and then plus 13, that's it. Minus this plus 13. C for Calcutta is the correct answer, right? I hope you guys are clear with this. Okay, the equation of one of the tangents to this circle equal to, okay, I don't think it is difficult at all, so you guys can do this homework, which is perpendicular to this line. Okay, so the slope of this line is 3 by 4. So the slope of a required line will be having, required tangent will be having slope equal to minus 4 by 3, number 1. Okay, so this will never be your answer. Rest of the things can be our answer, but we have just but we just need to see the perpendicular distance from the center has to be equal to the radius. So this is going to be 5 3. Okay, so we just need to see the tangent can be written like this. Okay, so 4x plus 3y plus k equal to 0, and we just need to see from this line, if we see the distance of 1 comma 2, it has to be equal to radius, then only it will be a tangent. So accordingly you can get the value of k and the question will be done. Okay, find the equation of tangent to the circle which lies at a maximum distance from the point this. Okay, find the equation of tangent to the circle this which lies at maximum distance from the point 2 comma 1. Okay, 2 comma 1 point is lying somewhere on this circle or not. Let's verify first. 4 plus 1 minus 4 minus 4 minus 4. Okay, so the point is lying inside the circle. Okay, yes. Okay, so the center of the circle is what? 1 comma 2. So the radius is equal to 3. Okay, and the point 2 comma 1 is, let's say, lying somewhere over here. Okay, so there will be, you know, the tangents like this as well as the tangent like this. Okay, we just need to see this distance is maximum when. So I don't think it is difficult at all. I don't think it is difficult at all. I think you will be able to solve this. Okay, this point may or may not lie on the common normal. Okay, keep this thing in mind. I think you will be able to solve that. Okay, standard notations as we have already discussed. If this is the equation of the curve, then S's value is going to be this, S1 is going to be this, T is going to be this. If this is the equation of the circle, then S is going to be this, S1 is this, and T is going to be this. Okay, so there are multiple uses of this S, S1 and T. Under root of S1 denotes nothing but length of the tangent. Length of tangent is what? Let's say this is a circle. And from this external point, if you are drawing a tangent, so let's say if this is the tangent, so the distance between this point of contact and from the point at which from the point you have drawn the tangent is nothing but length of tangent. So that value is nothing but under root S1. Okay. Yep. All right. Find the length of the tangent drawn from this point to this circle. So what you do is you first look over here. You first make the coefficient of x square and y square equal to 1. If you don't make the value of x square and y square equal to 1, then you're going to get the wrong answer. Again, I'm telling you, whenever you see the equation of a circle, first make the coefficient of x square and y square equal to 1. So, under root S1 is going to be what? Under root 3 square plus minus 4 ka whole square minus 7 by 2 into 3 minus 9 by 2 into minus 4 minus 13 by 2. This is nothing but your length of tangent. Okay. All right. I hope you guys are clear with this. All right. Moving ahead. Find a circle which is such that the length of the tangents to it from are this and this and this. I think you guys can solve it. You can check the options quite comfortably and the question will be solved. Always make the coefficient of x square and y square equal to 1. Okay. Power of a point is nothing but S1. Okay. Power of a point is nothing but the value of S1. You can evaluate it. Radical axis, now understand, radical axis of two circles is the locus of the point whose powers with respect to the two circles are equal. Okay, powers are equal. So the equation of the radical axis can be written like this. Okay, do remember this. If powers of point with respect to the two circles are equal, powers are equal with respect to these two circles means locus of the point P is what we want to find out. That means we need to find what? We need to find radical axis. And the equation of radical axis is what? The equation of radical axis is S1 equal to S2. Okay, that means just subtract the equation of circles. Just subtract the equation of the circles. The moment you will do this, 2x and from here 2y and from here plus 2 will be equal to 0 means the radical axis is x plus y plus 1 equal to 0. Okay. Or we can also say that length of tangents from those 2 points are equal. Okay. Yes, do try this question as part of homework. Okay, Q is any point on the circle, Qn is a perpendicular. Okay, we need to assume any point on the circle, so we can assume this point as what? 3 cos theta comma 3 sin theta. Remember, parametric form, whenever a point is needed to be assumed on the curve. Okay, Qn is a perpendicular drawn to the x-axis. Okay, so if this is Q, then this is n, and the coordinates of n is going to be what? 3 cos theta comma 0. Okay, find the locus of the upper point of the trisection of the Qn. Okay, if we divide this into 3 equal parts, then this point's locus is what we want to find out. So this point can be written as 3 cos theta comma 2 sin theta, yes or no? So its locus is what we want to find out. That means we can take it as h comma k. So h by 3 is going to be equal to cos theta and k by 2 equal to sin theta. Just square and add, you will get your answer. So the answer will be coming out to be an ellipse. Okay, director circle. Director circle is the locus of the point such that, let's say if this is a circle given to me and on this circle I want to draw perpendicular tangents only. Okay, let's say if this is the point, from here I can draw 2 tangents, one is like this and one is like this. If I always want perpendicular tangents only, so the locus of all these points from which if we draw tangent onto this perpendicular circle, onto this pink circle, if all those tangents I want them to be perpendicular only, then that will be nothing but director circle only. Let's say I want to draw tangents from here, the 2 tangents will be perpendicular only. So all those points from which if we draw a tangent to this pink circle are perpendicular, then those all points will again lie on a circle, and that's why this white circle is known as a director circle of pink circle. Director circle of pink circle. That means if you are drawing tangent from any of these points onto the pink circle, they will be perpendicular. Okay, okay. Let me tell you one very amazing fact. If this is circle A and this is circle B, so circle A and B will always be concentric. Circle A and B will always be concentric. Will always be concentric, means having same center, number one. And number two, if you see, if radius of A is equal to small a is there, then radius of B will be equal to root 2a. So from director circle, if you are drawing tangent, every circle has its unique director circle, number one. And from there, if we draw tangent to the circle, then they will always be perpendicular. The two circles will always be concentric, and the radius will be radius of the direct circle will be root 2 times of the given circle. Okay, okay. Find the angle between the tangents from the point 1 comma. Okay, can we write down the director circle of this particular circle? The director circle is going to be having radius 5 root 2, since this circle has radius this 5. Okay, so this is going to be our director circle. Yes, the radius will be root 2 and the centers is going to be same, concentric circle. Okay, so this point lies on director circle, means the angle between the tangents is going to be what? 90 degree. Yes or no? This is one way of solving this particular question. Okay, pair of tangents, be it, understand, pair of tangents means what? If this is a curve and from external point, as we have seen, two tangents can be drawn. So one is this, let's say a1x plus b1y plus c1 equal to 0, one of the tangent is this. Another tangent is, let's say, like this, a2x plus b2y plus c2 equal to 0. Then pair of tangents means what? Pair of tangent means what? If this is L1 equal to 0 and if this is L2 equal to 0. And the pair of tangents means L1 into L2 equal to 0, or we can say a1x plus b1y plus c1 times of a2x plus b2y plus c2 equal to 0. If you multiply this, you will get a 2-degree equation. Yes or no? So that 2-degree equation is nothing but known as pair of tangents. Understood, everyone? Okay. So that can be directly rewritten as S1 equal to t square. S is the equation of the circle. S1 we get by putting some point on inside the S, and t, I hope you know, x square replaced by x into x1, y square replaced by y into y1, x replaced by x plus x1 by 2, y replaced by y plus y1 by 2, and constant as it is. Okay, if any external point is given to me, let's say x1 comma y1, and by using that point, if I am writing down t equal to 0, understand, what do I get is nothing but this chord of contact. Remember, I told you that if you are writing down an equation by using an external point t equal to 0, that will not represent equation of tangent, right? When the point is on the curve, then only t equal to 0 will give us equation of tangent, otherwise that will not give us equation of tangent. Now what happens when the point is external? When the point is external, from the external point we can draw two tangents like this. Okay, let's say this is the meeting point of the circle and the tangent, and this is another meeting point of the tangent and the circle. If we join those 2 points, those 2 points of contact, what do we get is nothing but chord of contact, and that equation will be represented by t equal to 0 if the point is not lying on the curve. A very, 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 very important point. All right, moving ahead, equation of the chord whose midpoint is given. Now understand that if this is a circle, and how many chords are there onto a circle? Infinite. Okay, and let's say the midpoint of the chord is given to me. Okay, this is given to me. By just using this midpoint x1 comma y1, I can write down the equation of this chord. This is midpoint of the chord. Okay, understand one thing, if the midpoint of the chord is given to me, then perpendicular from the center bisects the chord. So if I drop a perpendicular onto that point, will it be that same point only? So that point is written as, that equation is represented as t equal to s1. So in order to write down s1, we use this x1 comma y1, which is midpoint of the chord. Okay, so if we want to write down the chord whose midpoint is given directly, we can write it down by t equal to s1. Do remember this. Okay, find the equation of the chord of the circle which is bisected at this point. Bisected means midpoint of the chord is given to you. So midpoint of the chord, midpoint of the chord is given to you and we need to write down the chord. How do we write it down? T equal to s1. So in order to write down t, x square will be replaced by x into x1, y square will be replaced by y into y1, x will be replaced by x plus x1 by 2, y will be replaced by y plus y1 by 2, and the constant term as it is, this is our t, and s1 is what? Simply put this point inside the circle. So minus 2 ka whole square plus 4 ka whole square minus 6 into minus 2 plus 10 into 4 minus 9. So this is nothing but our midpoint, chord whose midpoint is given. So this equation upon simplification will give us the chord whose midpoint was given to us. Okay, find the equation of pair of tangents drawn from this point. Okay, this point is external to the curve, feel it, because 3 comma 2 is a positive thing. If you put it any inside this, all the terms will be positive only, so you can say that this value is coming out to be positive, means the point is external. Okay, from the external point 2 tangents can be drawn. So if you write down those tangents and then you multiply them together, you get a pair of tangents. One way is that, another way is directly t square equal to ss1. So t square equal to ss1 if you do. So in order to write down t, what you do is x into x1, that means 3x, y square is y into y1, so 2y, plus 4 times of x plus x1 by 2, so x plus 3 by 2. Y can be replaced by y plus y1 by 2, so this is what you are doing. Okay, and this is 8. So this is our t. So doing the square of this equal to s. S is the circle's equation, x square plus y square plus 4x plus 6y plus 8 times s1 is what? Simply put this point inside the circle. So it is going to be 3 square plus 2 square plus 4 into 3 is 12 plus 12 plus 8. So this will directly represent you the equation of tangents multiplied. Okay, I hope you understood this. Okay, now talking about how the two circles can interact. Interaction of two circles. Understand. The number one thing is the two circles can interact like this. That means they are away from each other. Number two, if I bring them close, the moment they will touch each other, that will be another scenario, yes or no, like this. Okay. Number three, now the two circles can cut each other like this. Okay. Number four, now the two circles can touch each other like this, and last scenario is this, that is one inside the another. Yes, now understand it like this: the two circles are away from each other, you are bringing them close, they will touch each other. The moment they started touching each other, now they will cut. The moment they cut each other, there will be, if you go on like this, 2 points, these two common points will come, these 2 common points will come, and the moment will come when these two will be touching each other internally, and then this completely inside. So these are the 5 interactions possible between two circles, right? Number 1. Okay. Yes. Over here we can say that circles are away from each other. Over here we can say that circles touching externally. Okay, over here you can say that circles cutting each other. Over here you can say circles touching internally. And over here you can say that circle lying inside another. Completely inside another. Yes or no? Okay. Okay, understand few things over here. If the center of the circles are given to you, let's say C1 and C2, and the radius R1 and R2 is given to you, can you feel that over here the distance between the centers C1, C2 is what? Distance between the centers is greater than R1 plus R2 or not? Because the distance between centers C1 and C2 is going to be what? This distance, this green distance is, don't you think that greater than R1 plus R2? Yes. So whenever C1, C2 is greater than R1 plus R2, the two circles will be lying away from each other. Okay, observe over here, if this is C1, C2 distance, then over here, don't you think that C1, C2 will be equal to R1 plus R2? So if the C1, C2 is equal to R1 plus R2, the two circles will be touching each other externally. Okay, observe over here, this is C1, this is C2. This is R1, and over here it is going to be R2. So over here, can you feel that C1, C2 is going to be less than R1 plus R2 or not? Okay, over here if you see, this is your R2 and this is going to be your R1. So don't you think that C1 C2 is equal to R1 minus R2? So over here C1 C2 has to be greater than R1 minus R2 only. Okay, so whenever C1 C2 is greater than R1 minus R2 and lesser than R1 plus R2, the two circles will be cutting each other. Whereas if the two circles are touching each other internally, then C1 C2 has to be equal to modulus of R1 minus R2. And over here you can see that C1 C2 has to be less than R1 minus R2. Number one. So understand, if two circles equation are given to me, from there I can have their centers and their radius. Okay, and then I can find out a relation between distance between the centers, that is C1 C2 and R1 plus R2 and R1 minus R2, and accordingly I can place them in any of these 5 categories. Number one. Okay, now talking about number of common tangents. Observe over here, one tangent can be drawn like this, another tangent can be drawn like this, one tangent can be drawn like this, another tangent can be drawn like this. So the two circles can have 4 common tangents. So when the two circles are away from each other, 4 common tangents can be drawn. Over here one tangent will be like this, one tangent will be like this, common tangent, and another will be like this. So over here 3 common tangents are possible to the circles. Observe over here 2 common tangents will be possible. Yes or no, right? 2 common tangents are possible. Over here if you see, only 1 common tangent is possible, and over here is 0 number of common tangents possible. So there will be questions like how many common tangents are there. So first you will put these two circles in any of these 5 categories by finding out C1 C2, that is distance between centers, and also the values of R1 plus R2 and R1 minus R2. From there you will figure out that your circles are lying in which of these 5 cases, and from there you can predict that how many common tangents the two circles will be having. I hope you guys are clear with this. So if the two circles are touching each other externally, then these two tangents are known as direct common tangents, and this one is known as indirect common tangent, okay, or transverse common tangent. So this happens when C1 C2 equal to R1 plus R2. So there are 3 common tangents. When the two circles are touching each other internally, this was the condition. Okay, only one direct common tangent is possible, or rather only one common. Okay, if the two circles are intersecting each other, this was the condition. So here 2 common tangents are possible. Okay, and disjoint circles means the circles are not joined, or we can say that the circles are away from each other. So this was the condition. So over here 4 tangents are possible, out of which these external tangents are known as direct common tangents, whereas these internal tangents are known as transverse common tangents. Okay. Yes, one circle touching each other inside, this was the condition, no common tangent was possible in this particular case. Alright, orthogonal circles. Now understand what is orthogonal circles. If the two circles are cutting each other, then only the condition of orthogonality will come. Only in the case when the two circles are cutting each other at 2 distinct points. That means the distance between the centers is less than R1 plus R2 and greater than R1 minus R2. Yes or no? Only in this case. Now understand what is orthogonality. So there is this common point. Okay. At this common point, if you draw tangent for this white circle, the tangent will be drawn like this. And at this very same point, if you draw a tangent onto this green circle, the tangent will be drawn like this. If these two tangents are perpendicular, we say that the curves are orthogonal. You understood this? Understand. Only in the case when the two circles are cutting each other, that is in this scenario C1 C2 is greater than R1 minus R2 but less than R1 plus R2. In that case only we are going to talk about orthogonality number 1. Let's say the circles are meeting at this point. So over here we are going to draw a tangent onto the white circle. Over here also we are going to draw a tangent onto the green circle. If those two tangents are perpendicular, then we say that the curves are orthogonal. Number 1, this is the definition of orthogonality. And in orthogonality you need to remember this condition, very important. 2g1 g2 plus 2f1 f2 equal to c1 plus c2 if one of the circle is having equation x square plus y square plus 2g1 plus 2f1 plus c1 equal to 0, another circle having x square plus y square plus 2g2 plus 2f2 plus c2 equals to 0. The condition for orthogonality is 2g1 g2 plus 2f1 f2 equal to c1 plus c2. I hope you people understood this particular thing. Okay, find the c if the two circles touch each other. Understand, the center of the circle is going to be what? Minus 2x is there, so it is going to be 1 comma 0. Okay, and the center of the circle is going to be what? 0 comma 0. Okay, so these are the coordinates of C1, these are the coordinates of the C2, that is the center of the second circle. Okay, the radius of this is going to be what? 1. The radius of this circle is going to be what? Mod C. Yes, okay. Now the circles can touch each other externally as well as internally. If the circles are touching each other externally, then we can say that C1 C2 will be equal to R1 plus R2. So C1 C2 can be written as what? The distance between C1 and C2 can be represented as 1, okay, and 1 plus mod of C. So over here mod of C is equal to 0. So this is one thing, that is C equals to 0. Okay, whereas if you talk about the second thing, that is the circles are touching each other internally, then we have seen the condition was C1 C2 equal to mod of R1 minus R2. So if that is the case, then C1 C2 is nothing but 1 times of this 1 minus mod of C. So we can say that this 1 equal to 1 minus mod of C plus minus. So from here you can get the value of C, I guess, quite comfortably. So from there you can get the value of C. Okay, how many common tangents can be drawn? So in order to find out how many common tangents to be drawn for the circle, we first need to write down how the circles behave with one another. So 2 comma minus 1, the radius is going to be what? The radius is going to be 2. Okay, this is the center of this circle is going to be what? C1 C2. It is going to be 3 comma 2, the radius is going to be what? 9 plus 4 minus 4, that is equal to 3. So let's calculate C1 C2. So that is the distance between the centers. So 1 root 10. Yes, root 10. And what is R1 minus R2? R1 minus R2's modulus is equal to 1, and R1 plus R2 is going to be 5. So we can see that C1 C2 is coming greater than R1 minus R2 and lesser than R1 plus R2. So the two circles will be cutting one another, and if the two circles are cutting one another, how many tangents were possible? 2 tangents were possible. So 2 common tangents were possible. That's it. A lot of questions has been asked on this pattern in the recent years itself. Okay. A family of circles, the equation of the family of the circles passing through the point of intersections of these two. Understand, if these are the two circles, so there are 2 points of intersections. From these two circles, how many circles can pass from these 2 points? From these 2 points, how many circles can pass? Infinite. So how do we write down all those infinite circles? So this is S1 equal to 0 circle, this is S2 equal to 0 circle. We simply write all those infinite circles as S1 plus K, S2 equals to 0, where K is a parameter. Okay. Now, if there is a circle and there is a line like this, and from their point of intersection, if I want to write down circles, so there will be again infinite circles. So this circle is S equal to 0, this line is L equal to 0. How do we write down the equation of all those circles? We can write those infinite circles as S plus KL equals to 0. Okay, so to find the equation of the circle passing through this and points common to this and this. So let me call this as S1, let me call this as S2. So the required circle can be written as S1 plus K S2 equals to 0. S1 plus K S2 equals to 0. So the circle can be written as x square plus y square minus 6x plus 8y minus 16. This is S1. Okay, plus K times of S2, that can be written as x square plus y square plus 4x minus 2y minus 8 equals to 0. And since it is saying that your circle is passing from 1 comma minus 3, so solve for K from here, and the moment you solve for K from here, the moment you got the value of K, put it again in 1. Put it again in 1, you will get the equation of circle. Put it again in 1 to get equation of circle. To get equation of a circle. I hope you people understood this. Okay, so you can now attempt this question as part of homework. Okay, yep, attempt this also as homework. Okay. Yep, a few of the questions I am giving you as homework. Do solve these questions, as these are very good questions for your JEE preparation. Do solve these questions. Okay. One more concept I need to cover, so that I'll do. Rest all the concepts we have covered, so there will be no issue at all. Okay. Okay, orthogonality of the two curves, we have already seen this. Yes, so you guys can do these questions also as part of homework now. There has to be no issue at all. Radical axis and radical center, we have already seen this though, but still we can say that powers are equal, or the length of tangents are equal. So the radical axis can be written like this. Right, when two circles are intersecting, then the radical axis is nothing but the common chord only. Okay, if the two circles are intersecting like this, then this is nothing but radical axis only. So if this is S1 equal to 0, this is S2 equal to 0, then the radical axis is same as common chord. Okay, Yep. Okay. So this is direct question I'm giving you. I hope you will be able to do this. Okay. One more thing. This is homework. Okay. Yes. When two circles are touching each other, the radical axis is the common tangent. Okay. When the two circles are touching this, then this tangent is nothing but the radical axis only. Radical axis. Okay. This is also known as common tangent. Okay. Yep. You guys can do this question as part of homework now. Direct straightforward questions to remember the properties. Okay. Radical axis is always perpendicular to the line joining the centers. Okay. If let's say this is the circles and this is our then this is always perpendicular to the line joining centers. Okay. If this is the radical axis of the two circles. Radical axis is also the axis from where if you draw tangents on both of these circles, the tangents will be equal. Okay, if one of the circles completely lies inside the circle but not concentric, then the radical axis of the two circles lies outside in the same side also the two circles. Okay, if this is the case, then the radical axis will also lie over here. Okay. Yep. So this is also you guys can do as part of homework now. Okay. If each of the two given circles intersect a third circle orthogonally, then the radical axis of the first two circles passes through the center of the third circle. Do remember this as part of concept, and directly you guys, this is an important result. So based on that you can solve your question. The radical center of the three circles described on the side of a triangle are diameters. As diameters is the orthocenter of the triangle. Remember this result. Okay. Yes, so these are the few of the results which are important, because in coordinate geometry, if more number of results you do remember, the things are going to be easier for you. Okay, this portion is not mentioned in JEE syllabus, but this is there in JEE Advanced, so you guys can refer these short points for doing the questions, and you guys can attempt these questions, remaining questions, as part of your homework. DBP is also provided to you, so I hope you will be able to do that. I have another class to take as of now, that's why I'll have to end it over here only, but do attempt these questions, as these are very important questions, right? Okay, so this is one such family of thing. This is we have already seen, but over here I would like to tell you one important point, that most often what happens is that family of circles passing through the two given points is there, this point, and the kids are confused how to use family of circles in that case. So here you need to write down any one circle which is passing through these 2 points. So we can write down an equation of the diametric form, so that will be S, and we can also write down a line passing through these 2 points, so that line will be represented like this, and then we can use S plus lambda L equal to 0. Okay, so let's say if it is giving to me a question that write down a circle passing from 1, 1 and 2, 2. So by using these 2 points, first we will write down a diametric circle. Okay, so a circle is there with us now. By using these 2 points, we will draw a line. So we can find out the equation of that line, and then we have L equal to 0 with us. So then we will be using S plus KL equals to 0 to write down the equation of the family of circles. Okay, yes. All right, sometimes what happens that a point, only single point is given to me and one line is given to us, and the question says that write down the equation of the circles which are touching this line at this particular point. Okay, so in that case what do we do? In order to get one equation of the circle, we write down the equation of the circle of point circle. Okay, so that is what we do, and then line is already given to us. So let's say any circle touching the line at this point, means by using this point we are going to write down a point circle first, and then this is the line given to us. So S plus lambda L equals to 0 is what we are going to do, and the question is going to be solved, right? I hope you guys are clear with this particular thing. Okay, so accordingly you guys can do these questions. It will be easier for you now. Okay, so that's what I'm telling you. If you are doing this PDF entirely, I can tell you that you're gonna have some amazing command over this topic, circles. Okay, and all the relevant concepts for your JEE examination I have covered in this. You just need to solve these questions on your own now. Okay, then that's it. I will also recommend you to solve previous year questions, because previous year questions is the ultimate resource for your JEE examination. The more you solve those questions, the more easier it is going to be for you to, the more better it is going to be for you, because ultimate resource is your pre-YQs. So do solve that as well. That's it for the day. I hope that you understood something from this session. Keep learning, keep shining, keep rocking, keep enjoying. And if you guys have cleared class 11th, then I would like to tell you people that the more efforts that you're going to make today, it's going to be easy for you in the upcoming days. Otherwise, if you are not following revision of class 11th on a regular basis, then it is going to trouble you a lot. So do revise class 11th portion as well if you are now in class 12th. Alright, that's it for the day. See you all in the next session. Keep learning, keep shining, keep rocking, keep enjoying. Let's make most out of this. Love you all. Take care.